So I'm going to try a little experiment here on the channel, a little buy it, fix it, and maybe flip it type scenario. So what I got here is a NOCO Boost Plus. It's the GB40. And I got this from eBay for, it was like 40 bucks or something like that. And this one has, it was being sold for parts, as is, blah, blah, blah. And the other brief description was it's got a fake charging light. So we're going to verify that little complaint by getting a meter out and a USB charge cord. And we're going to see what it takes for charge. Well, first thing I want to do is make sure the thing's not brain dead. So we're going to see if it'll power up. And it does power up. And it's got 1 bar. So it may be too low to go into boost mode. So it does go into boost mode. So that's a good sign. And then we can use the little flashlight. So the flashlight also indicates that the thing is not brain dead. So that's good. So we'll hook our little charger up here to our micro USB port. And we got about 250 milliamps. So that being said, and with the state of charge of being this low, it's not charging at its full potential. So normally when these things are dead or very low on charge, it should be charging about 1.5 amps at best. Usually between 1 amp and 1.5 amps. That's all you're going to get out of these little guys. It's not like the X series where it's going to go into power delivery and it's going to give you 20 volts at 3 amps and stuff like that. It doesn't have that in it. So no matter what the size, if it's not an X series, doesn't matter what the size, it's always going to be 1.5 amps. So if you got one of them big monsters like GB150s or bigger, it's going to take a day just to charge it. So this one's not charging, so we're going to open this up and do some basic checks inside. And because sometimes these things have like a hereditary failures in them. Certain amount of components fail in them, or something gets overloaded or overheated and it craps out, or the battery is screwed up, or something like that. Or sometimes even the charge port is screwed up. But in this case, I don't think it is screwed up, because when you plug it in, you don't get any kind of funny business that's happening here. So all these guys are held together with a 2 millimeter triangle bit. So, and depending on the model, you're going to have to get a deep set. So you need a triangle type bit. And the bigger the pack, the deeper the holes. So you're going to need something with an extension on this. This one is about 1.5 inches long. So that's all you really need for the complete series, and no matter what model is. So we're going to take this apart. So now that we're working at the back side of this thing, we see all these warnings on the back of this thing. So I will issue a warning that you are dealing with a lithium pack in here that has some potential of going crazy if you do something stupid. So here's our lithium pack. So this is a lithium-ion battery. One of the biggest checks you want to do for these guys is make sure that this is nice and firm. So this thing is rectangular, and all the sides are nice and flat. It's not bulging and anything like that. So that's a good sign for this, that the battery is not, we'll use the term puffed. So what happens with lithium batteries is when they get old or they get abused, they get a little puffy. So something like this, I gotta put this on spot mode. Oh, so you see how it's not flat? These sides are flat, but you see how the top and the bottom is not flat? This is what you call puffy. So something like this, it's been around the block, it's been used, it's been abused, and this is something you want to watch for. Anytime you're opening these NOCOs, and sometimes it's so severe that you'll notice it even with the case on, because the case will be bulging. So if the battery pack is bulged, you're pretty much a done deal. You might as well just scrap it, because you can get the batteries for them. And I actually do have another NOCO, a GB40, and all the cells were puffed in it. So I'm going to make an attempt to fix that. So that'll be in a later video. But for right now, we're looking at this one. So overall condition, everything looks good. The battery's nice and firm. It's nice and hard. So no worries on that. And we got our little USB micro. This is our input. And this is another little item you want to look at to make sure it's not screwed up. Because what happens is that the bottom side of the port is split, you know, where they crimp it together. And when people throw in the charger and then they throw the pack on like a seat or something like that, or somewhere where it's the charger cord gets jacked, it jacks the port, and then eventually it breaks. So these little guys, they just are, some of these are screwed in and some of them just slip in. So this little guy just slips in. He's a slip-in type guy. And then we're going to have all kinds of jiggly bits and wires and stuff like that hanging out. So with this particular series, one thing we got to do is pull out the high current plugs in the pull it out of the base of the case of the jump pack here. So they're just a push to fit, and they slide right out, and there's no worry about for this particular model about shorting them together, because it's this big relay that controls the output of these. So we got that out. So the only thing that keeps this from pushing in, other than pushing buttons, because it's sitting like that, on the other side of the case here, not this particular one, but on the bottom side, there's a plastic bracket that's forked, so that holds inside the grooves of these connectors. Of course, I'm sitting on the flashlight button, so it's always going to be turning on and off and be annoying. So these little grooves engage with the grooves of the connectors, and when you're reassembling this, let's just say that the case is like this, your red cord will be closest to you, or it's going to be the square port of the charger or the jump pack. So the red for square, and then the black for the round. So that when you're reassembling this, that's what you want to look for. So another little common little hereditary problem with these is these connectors. If you drop this, it's very likely that these connectors can come undone, because they're just a friction fit, and it's not much to them to pop out. So we got two connectors here. This is the main charging connector. It's also the cell management. So there's 4 wires on these, and these are the balance or charging connector. and each wire connects to, one connects to the minus of the battery pack, the other one connects to the positive, and then the other two in the middle connect to the middle of each cell. So this is a 3S pack, so there's 4 wires. So we got battery negative, then we got battery 1, battery, the second segment of the battery, and then we were positive. So sometimes these can come undone, so it's something you want to watch for. In case these things are dropped, which, you know, sometimes they are dropped. So we don't have to worry about power when we touch these together, unless you trip the boost feature. So, you know, just for precautionary, you may want to put some tape on here or a piece of heat shrink, so we don't get any exciting moments. And then the rest of this thing here is just a relay that actually turns the output on and off. And then we got a bunch of diodes on here and switches and very robust solder connections. So that's that. So here's the other side of the board here. So we can fire up our little meter here and do some testing. So one thing we want to be testing for is various powers that are on the board here. So our first check here, and what's nice about the NOCO boards is they're actually labeled. So like over here we got our battery connections, and then we have another labeled test point here that we can check out. We got our 3.3 volts. So that's another thing you want to make sure you test when you power on, if it is able to be powered on, is check your 3.3 volts after you turn it on, because if there's no 3 volts here, this chip is not going to run. And then we got our common test points here. We got a ground, the main ground of the board. We have our 12 volts, which is going to be our battery pack voltage. And then we can also get our battery pack voltage here. So we got battery plus, battery negative, and then we got our 2 interconnects for each cell. So we can measure each cell to make sure it's not out of balance or stuff like that. Sometimes when a battery is not balanced correctly, sometimes the voltage is being detected by the charging chip here. Says, hey, there's one too many cells. It's too far down, and sometimes these chips will lock out, and you won't be able to charge the battery and stuff like that. So we got our main brain here. We got our charging chip, and then we got our MOSFETs for the battery controlling of the charging. And then on this end of the board, we got our 5 volts in, so we can test our 5 volts to make sure that, you know, the connector is good and stuff like that. So now we can just go ahead and start testing here. And on the board here, you might be able to see that, I think, or not. Got some glare. Let's see. There, we can see that. So we can go to here, and we can go to our 12 volts. So this is only going to register our battery voltage. So it's not currently on, so it's not going to register. But we can go right here to our battery ports and test the battery. So we got 10.4 volts, so the battery is, you know, low, but it's still alive. And then we can test our individual ports here. So our number 1 cell is 3.4 volts. And then we can go to the next one, that is 3.4 volts. And then we can go to our next one, and that's 3.4 volts. So all our battery cells, since this is a 3-cell battery, making 12 volts, is all within, you know, reason. And then we can go ahead and test the complete voltage. And then we can do the line them up, add them up. So 3 volts, 3.5, 3.4. We go to our next one in series, we'll go 6.9, and then of course the final voltage and stuff like that. So Our next check we want to do is make sure our charging works. So we'll go ahead and test our charging port. So we can go to ground here. See if we got 5 volts. There's our 5 volts, so that's good. And then we can go to our ground and make sure our... now that the board is powered up, we get a reading on our 12 volts. So we got our battery voltage, so 10.4. We can go over here. 10.4, so there's our... everything is working for our charge. So the charging works. Or I should say at least we got 5 volts coming into the board. And it is making the board light up, so something is being acknowledged. So then our other little test here is to make sure that everything is working. Is we can turn the board on, and then we can test our 3.3 volts, which is right here. So there's our 3.3. So we got our 3 volts here. So that's a good sign. So now the other hereditary possibility on some of these boards, and this is a newer board. If it's not charging, or if it doesn't turn on, somewhere on these NOCO boards, and it's going to vary depending on the board, there's going to be a series of resistors. They're going to be low ohm resistors, like 0.01 ohm resistors. And sometimes, depending on where it is on the board, is going to determine whether this board works. So on this particular board, this is a more modern one, and this is our resettable fuse right here. It's marked as T250. So, like I said, this is a newer board, but somewhere in the area there's going to be a resettable resistor. This is a resettable fuse. But in other boards, there's going to be a series of 3 or 2 0 ohm, you might as well say 0.01 ohm resistors. So, to test that, to test these resistors, because that's a common fault for these NOCOs, as the low ohm resistors go high. So something like this, when we test it, of course you got to get the right one. So when we test this, see how it's a low ohm? So if it said anything higher than 1 ohm, like if it was a 2 ohm, a 3 ohm, it could go into the kilo ohms and stuff like that. If it's high, they're bad. They've been overloaded, they're blown up, they're bad. Like I said, sometimes there's a series of 2, sometimes there's a series of 3, and if you test each one and they're high, then they're bad. See, like this is 0.3. That's acceptable for this particular one. So if they're higher than an ohm, like they're 1, 2, 3 ohms or higher, then it's going to be bad and stuff like that. So this particular resettable fuse is good on here. So the other thing that could be wrong is around here in the charge chip. So we can go around and check some of these resistors and stuff like that to make sure that there's no oddities. And of course, you would have to have a magnifying glass or a microscope to see the numbers on the resistors, so you can get what they're supposed to be. But anything around here is, like 5 kilo ohms, a kilo ohm, or something like that. So they're all within reason and stuff like that. And of course, you have to see the markings on the chip on each resistor to see what they're really supposed to be. And that's another good check that you can go around and just test various things to make sure that you don't see anything open and stuff like that. So another thing we can do here is, of course, we can check capacitors and stuff like that, because sometimes the capacitor can go open or short circuit and it can create problems. So we're just looking for shorts, and you can go, since these boards are pretty small, you can pretty much quickly go through all these capacitors. And sometimes you'll get a beep and sometimes you won't get a reading, and that's okay in some scenarios. But you're looking for stuff that's, you're basically looking for opens and looking for shorts. So we can test each element of them and make sure that like I said, you're just looking for shorts and looking for opens. So as long as you don't get a beep or anything like that, everything should be fairly decent on here. And of course, since this stuff is so small, sometimes it's kind of a struggle to determine what's a capacitor and what's a resistor and a diode. So we don't have any shorts as per se, or at least none that are that we can detect. And there's going to be a couple of capacitors on here that don't read, and it's because they're not connected through the board via ground or anything like that. So we pretty much went through all the capacitors, and now the next thing we can do is check some diodes to make sure that the diodes are okay. So luckily on the board here, resistors are marked as R, diodes are marked as D's, and then you got capacitors, they're marked as C's. So it's pretty easy to determine what's a diode and what's a resistor and all the other good stuff. So with diodes, you got to check them both ways. So you're just looking for shorts or opens. So as long as you get readings that are consistent with all these diodes, they're good. Because there's any number of things that could go wrong. So pretty much going through the whole board here, pretty much deciphered that the board is pretty good here. So I'm going to narrow it down to this charge controller chip right here. And this is the charge controller chip. Of course, I don't know what number it is because I don't have the microscope, so I can't really see what the numbers are. But I detect, since that we got 5 volts going in, it's powering up the board. We got a phantom charge, it's 200 some odd milliamps, but that is just the power consumption of firing up this chip, lighting up the lights, and probably a couple other little components on here, maybe even a partial startup of this chip but it's not doing anything because we got a couple of different controller chips on here. We got this one, this one, this one, that one. We got the main brain, and then we got our charge controller chip here. So I'm going to assume that this controller chip is dead, or at least partially dead, where it's not controlling the MOSFETs here to open up the current so the battery can charge. Because even when we plug in, the cell voltages are not increasing. So if it was getting an amp and a half put into the battery, these battery readings would be going up, and they're not. So we got a dead controller chip here. So in the next segment here, we will be doing a little swapping of the charge controlling chip here, and we'll see if we can resurrect this NOCO GB40. And if it's that easy of a fix, we'll flip it and make a couple of bucks on this, because it's kind of fun to do. Because it's one of them things I found on the YouTubes, because there's a lot of videos and there's a lot of channels that are doing the same thing that I'm doing. You're scoffing up these things because, you know, there's so many videos of how to fix these things. And I have to admit, I was snooping around and stuff like that because, you know, I was going through the other board there and trying to figure out what was going through all the checks of it, just to find out that the board is perfect. There's nothing wrong with it. It's just that the battery went to hell. And then when I tried to charge it, it was not happy. And that battery swelled up like a balloon, where I had to disconnect it and promptly remove it, because it was going wild. So that'll be another video. Of course, the next segment will be swapping out this charge controller chip. So it'll be just a flip of the page. Okay, now we got the microscope out. So now we're going to take this so-called bad charge controller chip. We're going to take it off the board, and we're going to put a new one on from a regular 3-cell charge board. So it's got the same exact number. We got an 8254AA, and then on this little charge board here, it's the same thing. It's a 8254AA. So same chip. So we're gonna make sure our take a visual reference of where the dot is. It's on the lower left-hand corner, and then we'll hire this bugger off and replace it. Hopefully that fixes this. So now we'll take the other chip off the donor board. Okay. So now I'll just touch it up a little bit. Alrighty. So that should take care of the chip. So now we will put the battery bits back in, and we'll see if this thing takes a see if it starts charging. So that'll be in the next segment. So now that we got the new chip in, time to reassemble this. So let's plug everything back in and see if this little charging circuit works again. So we'll plug that in, and then we'll plug our little temperature sensor in, and then we'll plug our little battery pack in. We don't have any smoke, so that's good. So now we're gonna plug in our little charging port here. And we got 1.3 amps, which is a hell of a lot better than the 0.25. So this was a successful repair. Of course, the amperage will go up as the battery takes a little bit more charge, but no more than 1.5 amps. That's about as far as it'll go. It's not like I mentioned earlier, the X series, where it's going to go into the power delivery and give you 20 volts at 3 amps. You know, if there is power delivery available. Otherwise, it does the same thing. 5 volts at an agonizing 1.4 amps or 1.5 amps at best. So that's it for this video. Thanks for watching, and we'll see you on the next video. Bye bye.